Hello friends, this video on coordination compound part 7 is brought to you by examfear.com. No more fear from exam. So with this, let's understand nomenclature of coordination compounds. We know what are the various parts in the coordination compound. We can visualize that. We can find the oxidation state of a coordination compound. Let's understand how to write the name of coordination compound. There are so many tons and tons of coordination compound that are being synthesized daily. So there has to be some ways to write the name. So IUPAC came up, that is IUPAC is the International Union of Pure and Applied Chemistry. It came up with the convention to write the names for this coordination compound. Okay, so we'll typically write the formula for a given structure and also we'll write the name for a given formula. We'll do this two things. So first case, the formula is given, we should know how to write the name. Or the second thing is, we have the name of the coordination compound, we should know how to write the formula. For example, NaCl is given, you know that NaCl is sodium chloride. If sodium chloride is given, you can say that sodium chloride is NaCl. Or CH4, you know CH4 is methane. If you are given methane, you can tell this is the formula. So both this thing you should know, right? From the formula, you should know the name, or from the name, from the name you can give the formula. Both things should be there. Okay. So let's see how can we write the name from a given structure. So let's assume that the structure is given to us. Okay. On the top, what you see is the structure, and we have to write the name. The first thing you have to do is you have to find which part is cation, which part is anion. So in this case, if you see, this has the plus charge. Okay, and this is a negative charge. Okay, so anion, we know that anion is a negative charge. There is anion, a negative charge, a negative ion actually. A negative ion is anion, a negative ion. So this is anion and this is cation. Okay, so it says that the cation is written first and then anion. So in this case, first I'll write this and then I'll write this. So writing this part is easy. This is chlorine, so it will be chloride. But writing this is a complex part is little complex. So let's understand how to write this complex part, the coordination sphere part. Okay, let's understand the name. So in this complex part, again, we have ligands and we have metal ion. In ligands also we can have various kinds of ligand. We have chlorine, nitrogen, we can have multiple kind of ligand, right? It may be homoleptic, it may be heteroleptic. So it can be heteroleptic complex also. So now let's understand in the naming of ligands, in the naming of complex, the first priority is given to ligand, right? So in this case, the ligand is given first priority and the second priority is given to metal ion. Okay, understood? First you have to write the name of cation. First figure out which is cation, which is anion, and then in cation itself, first ligand and then metal. Ligand is more priority than metal when you are writing the name. Okay, now if there are multiple ligands, there are some rules to write ligands. The rule is, if the ligand name ends with ate or ite, then we replace the last E with O. For example, oxalate becomes oxalato, sulfides become sulfito. If the ligand names end with ide, then ide is replaced with O. For example, chloride becomes chloro. Sometimes people write chlorido also, but chloro is also a common term. Water, if there is a water molecule here, we write aqua for this. If there is an ammonia molecule here, we write amine for this. If it is a CO molecule, we write carbonyl. If it's named carbonyl, it is NO, we use nitrogen. These terms are used. Please pay attention here. See, first thing is pretty clear. We have to write cations and anions. Cations are written first. And then if cation is a complex, then you should know the rules to write complex. In the complex, first the ligands are written, then metal. Rules to write ligands, I just described here. If it is a ligand that names end with 8, right, we replace E and we make it O. This E is replaced with O. Example, sulfide becomes sulfito, oxalate becomes oxalato. The ligand names end with IDE, the chloride, fluoride, it becomes chloro, fluoro, like that. Water is aqua, ammonia is amine, CO is carbonyl, and NO is nitrosyl. In case you have more than one ligand, for example heteroleptic complex, then alphabetical order is followed. If you have multiple ligands, for example we have 6 ligands, then bi, tri, hexa, those prefix are used. You see here di, tri, hexa, those prefix are used. But when you talk about the alphabetical order, you talk about the alphabetical order for the names of the ligands. Exclude that bi, tri part. Same concept which we use in the nomenclature of organic compounds, right? And for the polydentate ligands, for example EDTA, right? Those kind of polydentate ligands, they are all chill. For example, this guy is a polydentate ligands. Okay, so for this kind of ligands, we use this term. Instead of di, we use bis. Instead of tri, we use tris. Instead of tetra, we use tetrakis. I mean, bis is nothing from bi. Bi plus s, tri plus s, tetraki plus s, like that. So this instead of bi, tri, tri, we use bis, tris, and tetrakis instead of polydentate ligands. Okay, and if you now the next thing is, once you write the name of the ligands, you have to write the name of central atom. In central atom also, the oxidation state of the central atom will be indicated by a Roman numeral in parenthesis. We'll take one example to see that. Okay, and if the cation is complex, for example, the complex is cation, for example, in this case, the complex is cation, yes, then the normal chemical name is suffixed by this word ion. If it is a neutral complex, the neutral chemical name is used. If it is anion, then 8 suffix is used to as added to central atom. We'll see this rule in the same formula here. So let's try to name this particular compound. So first thing I told, find out which is cation, which is anion. So this is cation and this is anion. Correct? Now I told the first cation is written, then anion. So this part will be written first. Okay, so we'll write this part first. In this part also, first ligands are written. In this case, ligands are written first. So I have first ligand. Okay, and this is NH3. So NH3 is what? Amine. There are 6 NH3. So it will be hexamine. And there is no other ligand. So these alphabetical order is not required. So first I will write hexamine. Okay. This my ligand is done. The next is metal atom. So metal atom is cobalt. Right, cobalt. What is the oxidation state of cobalt? +3. We have seen that. So write 3 in normal. Since it is not ion, if this will be +3 ion, then we'll write here ion. But since this is not ion, we have a chlorine also added. So the next is anion. So let's write the anion. Anion part is chlorine. So I'll write chloride. Irrespective of it is Cl3 or Cl2, doesn't matter. We'll just write chloride. If this was only this chlorine molecule was not there, if chlorine molecule is not there, then we'll write here word ion. Then it will become hexamine cobalt 3 ion. Now it is hexamine cobalt 3 chloride. You got the point what I'm trying to say? This is how you write the name. Let's take one sheet where we have all these ionic ligands name. Br minus become bromo, F minus become fluoro, Cl minus become chloro, O2 is dioxygen, H2 is aqua, NH3 is amine. The same thing which we have explained, sir. C2O4 minus 2 is oxalato, Cn minus is cyano, OH minus is hydroxo, and CS3CO minus is acetoto. So those things we'll be using in the nomenclature. This is ethylene diamine. This is pretty frequently used, ethylene diamine. Okay, so we'll take some examples now. The first example is CrNH3 3H2O 3Cl3. The first thing is we'll find this is cation, which is anion. This Cl3 is a minus. This one is anion, and this is cation. Typically, when we write the compound, we write cation first. For example, if for example K and NaCl. This is a cation, this is an anion. That's how we write. So you may not have to worry also, but it's good to double check. But typically the first part will be cation, but we'll do a double check. So in this case, we can see this is a cation, this is an anion. So as per rule, cation will be written first, and then anion. In this cation also, in this whole complex, first priority is given to ligands, and then central atom. Correct? This is the rule we have seen. So let's write the ligand. So ligand we have what in this case? Ligand we have water, it is aqua, and ammonia, NH3, it is amine. Out of aqua and amine, which comes first? Both start with A. So let's see the next letter. This is Q, this is M. So this comes first, and this comes second. So first we'll write amine. How many amine? 3. So we'll write triamine. Okay. Then aqua. How many aqua? 3. Triaqua. We are done with ligands. Now central atom is what? Cr, chromium. Followed by the oxidation state in Roman. So for this oxidation state, this is 0, this is 0, this is chlorine minus 3. So this becomes plus 3. You can actually find the oxidation state for this. Pretty easy step. This is plus 3 oxidation state. So we'll write 1, 2, 3 here. Okay. So we are done with the cation part. Anion part, there is a chlorine. So we'll just simply write chloride here. And that is the name of this. Hope you understand what we have done. The first one, which is cation, which is anion. So first we wrote for the cation. This part was cation. In cation, we first wrote for the ligands. Ligands also we use alphabetical order. First amine, then aqua, and then my metal ions. So then my metal with the oxidation state, and once that is done, to the chloride. This is the anion part. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.